All right, so our last chapter review video. So nice work making it to the end. This one's gotta have a lot of formulas, right? So you definitely want to have the OneNote open because we're going to cover there's 4 topics that we covered in class, and like I said, there's a lot of different kind of formulas that we have to work through here. So I will try to go through some of these with the formulas. I'm going to use Excel just because the formulas are complicated. Not complicated, tedious, probably a better word. They're tedious. You can do them with a calculator. You don't have to use Excel. I'm just going to use Excel as the calculator so you can kind of see how I'm putting the numbers in since you cannot see my calculator. But again, you can do these with calculators. All right, so we're going to pop these out into 2 different windows so you can see both at the same time like we've been doing. So we're looking at loan fees here, right? And so we're going to take the loan fees, which is 175. And we're going to divide it by the 9-month period. So is 175 divided by 9 is 19.44. And you can see that is the answer. Right. So same type of problem. And now what do we determine? How much money we necessary to budget in order to cover expenses for attending local colleges? So this one we should be adding all of the numbers that go into anything to do with the university. Right, and so since estimated costs for all of it means we just have to add all of these numbers up. So again, see if we can copy and paste just to save time. Let's see if it does. Yeah, it did that weird double paste again. That's right. Instead of typing, I'll just delete them real quick like I did last time. Might have to ask Cox a way to put a little thing so you can actually just open this in Excel and see some time. So we're going to add these up by typing a sum, or if you go to calculator, just add all these up. Oh, we got to fix that top one. So we'll fix that. I don't know why I did that. So this is 19,739. So we'll also start with E7. There we go. And then we just divide that by the 9 months because that's how many long they wanted it. And you can see correct answer is 4812. Right, simple interest. Move our Excel out of the way for a minute. So our simple interest formula is this I equals PRT. So bring this back over here. Right. Just over those, you can see everything. So we need our I, we need our P, we need our R, well, a little R, and we need a little T, right? And we're looking for I. So that's what we're looking for. Our principal is our starting balance, which is 10,000. Not enough zeros. 10, 1, 2, 3. There we go. And it is for 30 years. So that's our time. And our rate is 5%, which we have to put that into a decimal, so that's 0.05. And again, to find simple interest, we take principal times rate times time. We get 15,000. All right, so there's a definition one. All right, so you have a credit card that has a balance of 1740. An APR, you plan to make $400 each month in effort to clear that. How many months will it take you to pay off the balance, right? So move our Excel out of the way for a minute. We were looking for our payment formulas. So that should be borrowing money. All right, so looking for our formulas, number of fixed payments to pay off a credit card. So that is the formula we need right there. The log, that horrible looking thing. We'll move this over so we can see it. And then what I'll do here is we'll move our Excel here so we can see all the numbers we have to type in. So we have a balance, BALANCE of 7140. We have a rate of 0.1599. Remember, move the decimal 2 places or divide by 100. Our payment is going to be $400. And we want to know how many months or time, right? That's what we need to know. So we have to use that formula. So I put all the information so you can see it. We'll move him over here for a minute. So we move him over here more. There we go. So we have to do this whole function here, right? So I need to do negative, equal sign, negative log, right? And again, you can do, I'm going to do these separately because it can be a little tricky to type this whole thing in your calculator. So we're taking the log of all of this that's inside here. So we're going to do 1 minus parentheses, the rate divided by n, right? And does it say how often it's compounded? Does not. It doesn't say we're going to go with months because credit cards are typically monthly. So then we'll put that into our formula here for a minute. It's going to mess it. That's fine. We'll put that there for now. I'll fix it here in a second. We're going to put 12 in there. Put this as a parentheses. And then we're multiplying that by parentheses our balance divided by our payment. And I need to close another parentheses because I'm taking the log of this whole thing. And it's going to give me an error right now because I haven't put anything for months. So we'll put in a 12 there. So our top number, our numerator, again, typos, numerator is that. And then we'll find our denominator, which again equals the log of 1 plus, again, my rate divided by my n gives me that. And so to find my final, how many long it's going to take to make our payments, I'm going to take my numerator divided by my denominator. And you can type this whole thing in at once, but you got to just be cautious where you put your parentheses. So this one, the big formulas, it might be better to actually do it. So it's more than, what do you want us to round to? Yeah, so it's over 20 months. So it means we're gonna have to make another partial payment. Won't be the full 400, but we'll make another partial payment to be our 21st month. And I don't know why I just shrunk that down. So let's see. So now we're doing an individual retirement account. So now we're not borrowing money. So that means we're saving money. So we go to 9.3. And what are we trying to find? Cameron starts an IRA at the age of 30 to save for his retirement. She deposits 400 annual interest, compounded monthly is when they tell us it's monthly. So we want to know how much you'll have at 65. So that is a future value problem because we're trying to find the future value, right? So now we have to use this formula. So again, I will name everything for this one. So here's our payment. We need a payment. We need our R. We need our N. And we need our T, right? That's what the formula says. So let's go here. We need more screens with all the notes we need. And you definitely want to have the notes, the formulas down, because this is just basically substituting the numbers into the correct formula. Try to shrink my Excel down so I can see all my numbers here. So our payment again is 400. Our interest rate is 6%, so that is 0.06. It's compounded monthly. They actually told us in this problem. And so he's 32 now, and she's going to 65. So I'm just going to let Excel do my calculation. 65 minus 32. So it's going to be 33 years. Now I'll move this guy over. And we find our future value formula. Right, so again, I'll do this in sections. So numerator and denominator, and then our future value is the formula we're doing. So our numerator is parentheses 1 plus the rate divided by n, close parentheses, all raised to the power. And since they're both numbers going to the power, I'm going to put a parentheses again, n times t. So this n times the time, close parentheses, and then we are going to close the parentheses again. Is that correct? No. -1. We have parentheses around the first thing, raised to the power of another, perfect. So there is our numerator value. And then our denominator is just going to be the rate divided by n. So that's how often it's compounded. And then our future value is just going to be the numerator divided by the denominator. That does not seem like a lot of money. Oh, that's because I've only done the fraction piece. I forgot to multiply that by the payment, right? So we've got everything but times payment in here. So we're going to multiply this by how much her payments are. There we go. That seems a lot better. So we can move this over here, round to the nearest cent. So we are good. This would be another one that's probably good to do in Excel, because if you make a small typo, it's easy to fix your formula in Excel versus in your calculator. So let's see if I did okay. 496, 567 and 90 cents. No, you can see it's going to take some practice. I understand that these are pretty tough, not tough formulas, bad wording, complex, right? So knowing what formula to use is key. All right, so for this one, so we're going to start an IRA again at the age of 36. So this one's very similar to the last one, but we know how much the end's at, right? So again, oh, my things got put into the same window here because I got bumped out. Let's move this guy over here for now. Bring back up our notes. God, everything got moved on except phone ring. I want you to pop out. There we go. So again, saving money. We are looking for, Seth starts an IRA at the age of 36 for retirement. He deposits $450 a month. Upon returning his retirement. So present value, future value. That's how much your payments are. All right, when I say this one should be a present value problem. So writing kind of strangely to me, but, and so we're going to bring up our Excel. On a new tab here. So balance is where we're ending. So 394,910.40. Again, our time is going to equal 65 minus 36. Got my equal sign again. So it's 29-year expand. His payment is $450. And so it doesn't tell what our interest rate is. So that is not going to be the right formula. Because there's no interest rate. Let's think, because we got to think about this logically. They're not giving us the interest rate because I want to figure out the interest, right? So if we think about this, if he 29 years, he makes a payment of $450 per month, right? So the total money Seth contributes, right, is going to equal payment times years times 12 payments a year for 12 months. So that's how much Seth paid. And now if we take our ending balance and subtract what Seth made, and that's how much interest. Oh, that's pretty good in interest. So this should be our total deposited of 156,600. That's how much Seth put in. And then this is how much Seth earned on interest. There we go. So I was trying to do a formula. So this not even a formula one. So some of these are going to be kind of think through them. Another definition. So let's Hale College predicts that in 12 years, it will take $200,000 to attend a college for 4 years. Hannah has a substantial amount of cash and wishes to invest a lump sum for her child's college fund. How much should Hannah put aside in an account with an APR of 8% compounded monthly in order to have a future value of $200,000 in an account in 12 years? So this is a future value problem again. So we've already done one of those problems. So payment rate, right? Actually, no, it's not a future value. We need to know present value. We'll do this problem to be sure. I think this might be a present value one. So we can stick to the problem we just did sort of a minute ago. So 200,000 is where we want to end up. Sure, I got the right zeros in there. Yep. Time again is 12 years. We don't have a payment for this one, but we have a rate of 0.08%. And that should be all that we need. So first we'll figure out, actually, no, we don't need to do all that. So to find our present value, what we have to start with, right? That's because he wants to know what we need to start with. This equals where we want to end up divided by, in parentheses, we're doing, oops, bring my Excel over here so we can see it. 1 plus rate divided by, and then we will again assume it's compounded monthly, so I'll just put a 12 in there. Raised to parentheses 12 times 12. I forgot to put my compound above, so I just put in 12. And now I got to add, I'm going to add another set of parentheses just to make sure Excel knows I want all of those numbers to stay in the denominator. Right. So again, you could do it in separate pieces you want. I did that one all at once that time. And so 76822.93 is what she should start with to get there. Yeah, so this is a present value. Present value is what is my starting balance to end. Future value is I got a starting balance and I want to know where I end up. That's kind of the difference between these two formulas. So present value, you know where you want to be in the end. Where do I start? Future value, I know where I'm starting. Where will I end? All right, so for this one, all right, clean up some of my numbers here. So it's the depreciation. We did one of these kind of like, I don't remember the chapter now, but if it dropped by 10%, which means your original was 90%, so your current value is 90% what it was, right? So if I take the current price and I divide it by 90%, then we had one of these on the test before, very similar, 23,333.33. All right, and the reason, if 10%, this is the new, which is 10% less than the old, which means this is, the old is 90% more, and you divide. And again, I think I've showed you this before, algebraically why, but we've done problems similar to this. I want to say it was back with percents, yes, so chapter 4. All right. It was to say for 10 years and purchase the house as a value of 150,000 with cash. If they deposit the money into account paying 6% interest, compounded monthly, how much do they need to deposit, right? So they need, this is a payment problem because they're saving money. So we are going to use the payment formula here. So again, we'll bring up our thing. Our A is 150,000. And they're going to do it for 10 years at 6%. All right, this was present value formula. We are now going to do, because they want to know how much their payments are going to be. So we're using the payment formula. So bring back up my Excel, bring this guy over here, delete all this out for a minute. You probably could create an Excel file that would have all these formulas pre-built, and then you could just put the numbers in them and it would be a lot quicker, but that's fine. So we are going to do these in pieces again. So we'll do numerator, denominator. So our numerator is a little bit easier. This is just, again, rate over compounded. I think it said monthly. Yep. I always forget to put in my monthly compound here. That's all right. We'll just type it in. So this is going to be rate divided by 12 for compounded monthly. And our denominator, which has a lot going on. So I'm going to put double parentheses because I got to put it. Man, no, I don't need double parentheses. I am going to do 1 plus the rate. That's why it's not working. Helps if I put an equal sign in there. Equals 1 plus the rate divided by n, which again is how often it compounds is 12. I'm going to raise that to n, 12 times 10, which is 10, times years, which is 10. Yeah. Right, so that takes care of that. And now the formula says to subtract 1 from it. So there is my denominator. And now to find the payment, I take future value. And I am going to multiply that by my numerator divided by my denominator. And so my payment is $915.3075, so $915.31. $915.31 is what I need to put away if I want to pay cash for my house in 10 years. A couple deposits, 22,000 account. Here's another future value. So I think we've done a couple of these. Be careful. This is a weekly problem. So there's 52 weeks in a year. So instead of doing the n is 12, n is going to be 52. But we've done a future value. So you want to purchase a house, you take home pay is this. You wish to stay recommended guidelines for the mortgage balance by only spending 1/4 of your take home pay of the house payment. You have 18,600 saved for a down payment. So this is a borrowing money problem. So there should be a formula that's payment, max purchase and price. Yep, What is the total cost of your house you can afford? So we are doing the max purchase price formula. Which I got a couple of my old notes here, so let's erase these and get them out of our way so we can see here. I gave it better writing these on the side so that when people get open in different formats, they don't get in our way. So let's go to our Excel. Your take home pay, so this is our pay. 43, so this is our pay. 4310. We want to stay within the recommended guidelines, only spending a quarter. So this is how much we can, this is our payment amount, is going to equal 1/4 of this. So this is that times 1/4. Right, so that's how much we say we can pay on the house. We have a down payment of 18,600. Oops. So save 18,600. And we are got a rate of 0.0575. And our time is 15 years. So even if you're doing this on a calculator, I would encourage you to write down what everything is. So when you go to put it into your formula, we can call it up. So again, we'll do, again, our numerator, denominator, and then we'll do our price. Right, so numerator is going to be 1 minus parentheses 1 plus. You can see the formula does the same things over and over again. I forgot to put my n in again. And make sure it is compounded monthly. If it doesn't tell you, go with monthly. It does not, so we'll go with monthly. So we're going to do our rate divided by 12 raised to parentheses a negative 12 times 15. And then our rate is equals this, again, divided by 12. And then our price is our payment times numerator divided by denominator. And that's how much of a house we can afford. So 129,755.20. Let's make sure that's actually a 0. No, see Excel, make sure you make your things big enough. Sometimes Excel is going to round on us. We don't want it to. So that's 167. So that is 17 cents. We had trouble with that before. So make sure your columns are big enough. What? 129,755. What does it want me to round to? Man, near a cent. All right, what do we got? What did I miss here? 575, 15 years. No, we forgot to deduct we have a down payment, right? So we get to add on our savings. So if we didn't have the savings, that should be the right answer. Now that we save some money, there we go. So don't forget to put in your savings because that's not part of the formula, but because you have this, that was the max you could pay without. So if you actually have the savings, then you can pay a little bit more. Again, I make the mistakes so we all can learn together. All right, so consider a credit card with a balance of 6,000, APR 16.9%. In order to pay off the balance, what is your monthly payment? So here's another monthly payment one. So again, borrow money, payment formula. A store is having 60% off sale if the sale price, what was the list price? Again, take that, divide by the complement of 60%. So 170 divided by 0.4 should work. Divided by 0.4 goes $425. So those are very similar to chapter 4 questions. All right, suppose you like to save enough money to pay for a car. Your goal is so this is a saving problem. All right. Suppose you save enough money to pay for a car. That's a payment one and saving money. So we go to saving money. We've done most of these already. So there's our future value. So again, this is future value. Simple interest, we've done one of those. Bought a new car, finance to make the purchase. This is a compound interest problem. All right, so this is just reading off a table. Determine the effective interest rate. Oh, annual APY. There we go. We haven't talked about that one. So this is under personal finance. No, where is it? Where is the APR? Ah, here it is, right here. Determining APY. Oh, the equation's loading. Come on. Cancel. I'm even at work where the internet wants to be slow. All right, so finally our equation loaded. So we're gonna do annual percentage yield. So let's make this small again. I don't know if that was what was causing the issue, but we'll do it anyway. So if it's a less effective for a loan is less than 20,000, so that means we're gonna use 14.25. So that is our rate. And it is compounded quarterly, right? So we're going to do tab just so we don't confuse our numbers here. So we know our rate is 0.1425. It is quarterly, so N equals 4, because there's 4 quarters in a year. And I don't think we need the 20,000, but we'll. Nope. So we'll bring back up our Excel. Oh, we need to see the formula only has R and N's in it. So we're trying to find our annual percentage yield. So this equals you can see the formula is basically compound interest moved all around, but they just did all the work for us. That's why it's the same thing over and over again. So 1 plus the rate divided by our N, close parentheses, raised to the N, right? Minus 1. And then again, that's going to become a percent. So we're just going to multiply by 100 or move our decimal 2 places. And it wants to round us to the 100th. So just so you can see that, I will multiply this by 100. So I'll move my decimal for me. So this is 15.03. The value of stock invested decreased by 39% after the stock market crash. What percent of, percent increase formula. So if we go to personal finance, we've done this problem before in chapter 4, so I'm not going to do it, but just to remind you, percent change, new minus reference divided by reference times 100, right? So they already give us the decrease. So what do they want us to do here? All right, so that wasn't as easy, wasn't what I thought it was. Define percent change, new value minus reference value. Okay, so this is the right formula. So we need new value minus reference value over reference value times 1,000, right? So we need a starting point. So let's say our stocks were originally $1,000, right? And then the value of our stock decreased by 39%. So again, if I take 1,000 and multiply that by 0.39, it was a $390 drop, right? So, oops, escape. So if we equal this number minus the 390, gives us 610. So now we have the values that we need. So our new value is 610. And we want to get back to our starting point of a reference value. Oh, oops, I put my equal sign in. No, we're at 610 because we want to get back to 1,000. So equals 1,000 minus 610. Fine, I'll do it this way. And then we're going to take that and divide it by our starting point, which is 610. So we actually have to do how many decimal places? Nearest 10th. So 63.9%, 63.9. Yeah, so a little tricky, that one. I was thinking we're missing something. That's why I was like, this can't be that easy. It's not. So pick a starting value. I like 1,000, but you can really pick anything, right? And then you're gonna figure out how much you lost in the stock market. And then you will have a starting amount and then amount you want. Remember, you want to get back to this. So this, when you find out how much you lost, that becomes your new starting amount. And then you go through and use that formula. Use the formula to present value, right? So that one tells you the formula to use. So I think we've done that formula a lot. Here's another one of a total cost of a vehicle and an inflation problem. All right, I think I've done enough where you can see how to use the formulas. Email me if you have any questions, and excellent work finishing the last chapter's work. As always, have a good day and email me if you have questions.